Thanks for joining me here on the Ozzstar's Cars channel today. I'm Glenn, and today's fun project, we've got a 2017 Ford F150 behind me. It's got the 5-liter V8, what they call the Coyote engine. And the issue is, or customer complaint is, there's an engine knock or tick or click, whatever you want to call it. It doesn't sound good, and the owner was concerned. He brought it to me. What happened, give you the backstory real quick. This truck's been to 2 different shops. So one shop suggested that possibly there was something caught up in the top part of the engine that had come apart. It was making this clicking, clunking, clanking sound. And he suggested that the truck be brought to a Ford specialist who deals with Coyote engines. He looked it over, or actually suggested an engine replacement, and wouldn't know what was wrong with it until the engine was pulled out. So the owner brought the truck to me, getting basically a third opinion. And today I want to bring you in on what's going on. All right, so I got the scan tool fired up, the Bluetooth dongles in. I just saved you guys some time here. We don't need to show you how to set that up, but I ran a full test for diagnostics for codes. We're going to go into the powertrain control module. There you go. And we're going to fire that up. Now with this we have active tests. The codes I checked, I'm not sure what they are. They weren't any codes for that servo for our actual intake runner, which I believe, don't hold me to it, but if it's different, I'll change it here. I'll put a text in the video. I believe it's a P2004, or you might get a P2005, which is bank 1 or bank 2, that the runner control is out of whack. Now this one, for some reason, there is no check engine light on in this truck, and there is no code coming up for that. Not sure at this point why it isn't, but maybe just because it's loose, it's a rattle, and the runner is actually functioning, so that's probably why it's not seeing any problems. Let's go to active test. We'll let this load up. And then I want to get over here to, let's see, right here, intake manifold runner control. Okay. Why did it just kick me out of that? Let me go back. There we go. Okay, so here's our intake manifold runner control, and basically what I can do is I can command, there's, like I said, there's 2 runners in there. I can command them on and off. So right now it's saying it's on. What we'll do is I'm going to have Scott hold the camera. I'm going to go back here and show you guys how I hit this on and off. And what we want to do is here, right back on top, you can see that, we'll call it that silver, like kind of corroded bracket right there. That's a solenoid in there, okay? And we want to hear that clicking and clacking, just like it was a purge valve or some other solenoid you were testing, a vent valve. You want to hear the clicking. Now clicking doesn't mean it's working, okay? That just means it's functioning. It doesn't mean the valve's actually open and closing. Something's moving in there, that's a good sign, but you always want to test with like a vacuum pump. So you can see those vacuum hoses on top of that one. It's right here on that servo. That's for this runner, and the other one, like I said, is behind here. We can't see it right now. And we should hear clicking. Now the ignition is on and we are hooked up. Okay, hopefully you heard the plunger on we heard a solenoid click, but we also heard the plunger move, which was on the servo. So that's a vacuum operated, there's a diaphragm in there. Let's turn it back on. Okay, it's running out of vacuum now, but we definitely hear the solenoid clicking. That's good. We're going to hear, or hopefully you guys can hear the knocking or the rattling, I guess. That's a better term for it. There's a loud rattle. And anytime you want to diagnose a problem like this, you basically, what I do is I try to isolate where the noise is coming from. So is it the top of the engine? Is it, in this case, this would be bank 1 over here. This is a V8. Is it coming from bank 2? Is it possibly coming from the front of the engine, okay, where you have all your pulleys and your water pump and alternator and all that stuff? So I kind of isolate it into those 4 areas. And what I'm going to have Scott do, he's the owner of the truck, he's inside the cab. I'm going to have him fire this up. Now, the symptom that he was telling me here was, at idle, there's no noise. You cannot hear the abnormal noise. Now, we will hear the injectors clicking and stuff like that, but this is an abnormal, louder tick, and I hope it shows up or comes up here on mic, you know, on the audio so you guys can hear it. And he's only hearing it around 1400, 1500 RPM and up. So at idle, it's fine. So we'll have him start it. Now the engine is cold. It'll high idle for a second. We'll let that come down, and then we'll show you what's going on. So Scott, if you want to go ahead, start it up. Okay, so it's just high idling. I hope you guys can hear me. We're gonna let that idle come down a second. Let me show you the tack here. So right there, I don't know if I can get it, there it is. So we're about what right now? Just about 1400. So we don't hear any ticking, we don't hear anything abnormal. And what I'll do is I'm gonna let the engine warm up here for a minute, and then I'll fire the camera back up. Okay, the engine's been running for a couple minutes. The idle's down. I think it's about 1,000, but that's good enough. I just want you guys to hear the difference. I'm gonna have Scott bring the engine up to about 1500, 2000, and let's see if we can hear it. I'll hold the camera in, and hopefully you'll hear this clacking sound. All right, Scott, go ahead, bring it up to 1500. Okay, let off. Let off. Okay, I hope you guys can hear that sound. Can you bring it up to like 1500, 2000 again? All right, let off. Okay, so hopefully you heard it. That's a distinct clacking. Now back here, this is our intake manifold. This is where I'm hearing the sound. I'm not hearing it over here, and I'm not hearing it over there or up front. I'm hearing it right up in this area, and it's more pronounced back here. So basically, what I did, or what I've done here, is I can hold this servo back here. This controls these runners. So why don't we shut the engine, I'll tell you a little more about it. All right, so you hear that clacking or clicking noise. A lot of people would confuse that with something loose in the engine. Let's say like a rocker arm, the bearing, the roller bearing goes bad, and this thing's clacking around. That's why I focused and I used this one of these stethoscopes right here. So it's called a mechanic stethoscope, one of these, and you just hook it up just like the doctor does. Call me Dr. Ozzstar, I guess. And you take this point, and whatever you touch it on will increase that sound. Comes right up through here, and you can hear really well with it. So, or at least it helps you determine or find where the cause of that noise is coming from. So I had put one of these on. I can't show you myself doing it on camera, but what I did was poke around. I went over to the valve cover. I went to the top of the intake. And now, by the way, these intakes are plastic. I put this right up against it, and it seemed like the more I went towards the back of that intake, it got more pronounced. So I knew it wasn't at the front or on the side banks. So right there, we're talking about the intake manifold. And the intake manifolds on newer vehicles have what's called runners in them. Now these runners are sort of like an old school, like a carburetor has a butterfly flap, and there are flaps in there, and what these do is basically control the airflow into the engine. So the computer decides that. It has to do with performance. Like in this case with an F-150, we're looking for torque. So by controlling the amount of air that goes into the cylinders, we'll control somewhat of the performance with the torque. Like the Mustangs that have the 5.0 liter Coyote, they're more for horsepower. So they're designed a little bit different. They're lower profile. Anyway, that's the whole engineering aspect of it. But on the back of this intake, there are two what we would call servos, and they're controlled by vacuum pressure. And there's a little electronic solenoid that's run by the computer. When the computer, or when it commands these flappers to move, then it will open and allow vacuum to flow or cut vacuum off. So basically the solenoid moves these flappers. Now I can't show you how it operates because it's still in the truck, but I will show you one on the bank one on the back that you can see. There's actually two of them. One of them's lower. What I think I'll do is I'll put a picture here in the video and give you better detail what I'm talking about. But anyway, Those solenoids are electronically controlled, and what we'll use is our scan tool. I have the Autel MS906BT is a bidirectional scan tool. You can use that to command this solenoid on and off. So what I want to do is we're going to fire up the truck. I'm going to get Scott to bring those RPMs up again. We're going to hear that clacking, which you're going to think is like a valve train problem, but it's not. I'm going to turn it on and off. I'm going to show you guys exactly what I do to diagnose this problem. Something I want to add in here is that when Scott was driving down the road, he could not really hear this noise in the cab. You can definitely hear it outside the truck. Even with the hood shut, it's very pronounced. So if you hear some ticking noises going at lower RPM, like 1500, 2000, let's say you stop at a stop sign or a red light and then you go to accelerate, before the engine noise kicks up, you'll hear that ticking. You may hear it in the cab somewhat, so just keep that in mind. Anyway, let's get back under the hood and let me show you what we're going to do next. So before the engine gets too hot, we're going to do our little test here to prove that it's just these intake runners and we don't have major engine damage. So I'm going to turn the runners on and off. Right now they're off. Scott will bring it up to 1500, 2000, and then we'll shut it on and off, and we'll do this a couple times. All right, go ahead, Scott. Okay, let it steady out. You hear the clacking? Keep it clacking. Keep it in 2000. Clacking's gone. I'll turn it back on. He's holding the throttle. That's off. This is on. When it's on, it's nice and quiet. I hear the plunger moving back and forth. We'll do it off one more time. There you go. Okay, you can lift off. So anyhow, I don't have to shout now. You can easily see with the bidirectional control scan tool that we diagnosed that problem to this runner. Let's wrap this video up here. So what I want to tell you is basically the runners in that manifold are flapping around, okay? They're flopping around and you're hearing that clicking, clacking sound. So don't panic if you hear this noise. It may not be, total engine loss. Now, the owner was told to replace this motor or engine would be about $9,000. And the only way they were going to be able to diagnose or find what the problem was is at first just pull the engine out and take it apart. So I kind of proved to the point here as far as what's going on. There's no need to pull the engine. We'll just pull the intake manifold. I'm sure he'll be getting that replaced in the future. The unit comes as one piece. You really can't maintain or work on that runner. It's all built in, so to speak, because it's molded plastic. I think they're about, I don't know, they're usually $300 to $400 and just for the part. And that comes with the new servos and a solenoid and all that fun stuff. So basically that would be the next step. Remove the manifold, intake manifold, and see what's going on there. Now, as far as anything else here, I think that pretty much concludes it. If you do not have one of these fancy scan tools, and by the way, if you don't own a scan tool that's bi-directional, it does not give you the answer. It just helps you with the diagnostic process, okay? It's not a magic box, but a lot of people believe it is. The thing here is what you can do is on the back, it'd be a little tricky, it's hard to get to. You could energize, I should say, that solenoid. So by applying 12 volts directly to the solenoid, at least you could hear if it's clicking and clacking. Now, what I'm going to tell you is if you're not hearing that, most likely your check engine light will be on and you'll be getting a code for that. So in this case, it's working. There is no code. It's just a loose runner. Okay, so in true Ozzstar Cars fashion, here we go. The old manifold is out, and I want to take you over to the bench and show you some details on here. Now, when you purchase a new Ford OEM intake manifold, you get all these guts on the back. We're going to go over that in just a second. The only other thing you'll need is the gaskets on the bottom where it seals and the throttle body round gasket there. So let's go to the bench. Your air comes in through here. You have your air filter, the tube, out here. You have your air tube, goes into here, sucked in, boom, right? Goes in here, goes through these runners, through this, or manifold, I should say, and then comes out past these runners down into the engine. Let's take a close look at what we've got going on back here. Now this was facing the firewall. All we could see was this servo right here, or actuator, you could call it, this big round thing. You've got one here on this side, that's the passenger side, that's bank 1, bank 2's over here. And you know, you could call them actuators, when what they do is there's a diaphragm and this moves in and out through vacuum suction here, which turns, and I'm going to show you these runners down in here that go all the way through in just a second. But in the meantime, so you've got these two. Now I took this screws out of this one. I want to show you. I'm going to take it off here so I can show it to you. Here's a sensor. This monitors the position of that runner, that actuator, whether it's moving or not, so the computer knows if it's working. Now this is up here, these two, these solenoids, these vacuum solenoids, this is what Ford calls an engine air shut control assembly. That's a big term for that. What happens is vacuum, engine vacuum is down here, comes through to this little plastic manifold and splits it into two ways. So you got vacuum going to this and vacuum going here. Well, this controls that vacuum, is all this does electronically. So that's the clicking that we heard when we were using the scan tool. The computer will turn these on or off that way. So it takes a electronic solenoid, and then that opens. It's like a gate. It allows vacuum to go to these solenoids, or these servos. Let me show you this one. I'm gonna pull this one off real quick so you can see it right here. Okay, and this piece just slides on right here. I'm going to show you. That turns, and that's your actuators, your runners, I should say, not actuators. And let me show you how this works. So basically, this comes, let's see, if I push, there's a diaphragm in here, okay? And up here is where our hose, this hose right here, goes into there. Okay, so that's supplying vacuum. When that's open, when that solenoid opens and lets the vacuum suck this all, oop, I couldn't show you, sucks that in like that, right? I'm gonna hold my finger over top. So basically, when that solenoid cuts off the vacuum, this cam right here is going to, or crank I should say, pop right out. Watch, I'll release this in one shot. Okay, so that's how that works. So when that does that, this turns, this piece right here, this is a cam right here, this part, okay? Turns this rod here. Now the rod goes to that runner, and I think in here is where our vibration issue was going on. Now the manifold, like I said, was replaced. This is the old one. So as soon as that was replaced, no more rattle, and I think that's where our problem is. So I think I explained everything out here. The only thing I didn't show you was down here. Let's get this one. This is our map sensor. So manifold absolute pressure. Okay, that's another sensor down there. And the only real way to get this stuff unplugged, these connectors, since it's so far back, you can loosen up your intake, kind of get it loose sideways, pull it forward a little bit towards the front, and you got to reach down in here and unhook this stuff. There's also another hose right here. I believe that might be PVC. But anyway, enough of that. Let's flip this up. Did I say PVC? I meant PCV. Then again, that could be on the front. We're not here for that. So let's go over here, and let me see if I can do this with just one hand. I got to get my light. And here's that. Here's the rod here. See that this is sitting on like this. Okay, so that's turning. When this plunger goes in and out, that turns. And let me show you what's going on right in here. So, shut my light. I'll try to hold this as steady as possible. You guys look down in here while I turn this right here, and you'll see those flappers. So right there, that's cutting the air off. You can see like 75% of it's cut off. There's just a little bit of hole, a little bit of opening right there. And then when I open this, boom, wide open. So we got full air flowing into the engine, okay? So that's what we're looking at right there. That's what's going on, and I think these were probably rattling in here like this. You can kind of, you know, simulate it when it was at that 1500 to 2500 RPM, and that's what's going on. So in true Ozzstar Cars fashion, I wanted to give you guys the update. Thanks for staying around this long if you have. I hope the video helped you out. In this case, 3 diagnosis, 3 times a charm. So this was a good call. I know the owner's very happy. He did not have to spend $9,000 on an unnecessary new engine. So that's a good thing. Other than that, I am going to end the video for real this time. So leave your questions and comments down below, and smash the thumbs if you get a chance. Appreciate that. Subscribe, and that's about it. So I'll see you on the next one. Take it easy.